you, Ben.
I'll be right back.
Okay. Good morning, everybody. We are group number 3. We are the eco-friendly shallow draft boat team. Let me present you the team members: Domingo Malave, David Nair, Jose Raul, and myself, Sebastian Lopez. Our project advisor was Dr. Claudius Carnegie. This is a brief overview of what we are going to cover during this presentation. We're going to go over the sponsor, the problem statement, design alternatives, whole design, all the way distribution, final design, the PV system component manufacturing, the breakdown, cost, timeline, division of labor, and finally global learning. We would like to thank our sponsor and support, Mr. Norman Werman. He's the president of Onyx on the Bay Condominium Association. We also like to thank Ralph Brown, founder and owner of Green Boats Inc. I don't know why he's not here, he was coming down. And we also like to thank Dr. Claudius Carnegie. Next slide, please. Our closing statement, Mr. Werman approached us with a project design. He wanted to build a boat that carry around 15 passengers from Biscayne Bay to a small island. The distance between these two places is around a mile. He wanted the boat to be mainly powered by solar energy and have a battery storage. We were told at the beginning that they wanted to do a design. They don't want us to do a manufacturing or a prototype. We have some constraints, rules, and regulation. It has to be shallow draft, 1 foot depth below water. It has to be handicap accessible, and it has to meet the local environment regulations and rules. Now Jose is going to talk about the design alternatives.
Well, some of the design alternatives, basically we consider 3 design alternatives. The first one, the V-shaped hull, then the round bottom hull, and the pontoon hull boat. Basically the V-shaped hull, we didn't use that one because of the stability issues, especially when it's riding at lower speed. The round bottom hull, because of the shape of the hull, we were not going to be able to reach our goal, that is 1 foot of draft. Then initially we started working with the pontoon hull boat. Basically, after consulting the boat manufacturing, we decided to change that design, because here in North Florida it's not good for the wave, and that kind of boat is more used for lakes and like spaces with no wind. As you can see here, we have the catamaran hull design. Our design is, well, this is the bottom part of the design. We have like 2 different sponsors. Basically what we did, this is like a cross-sectional area, a square cross-sectional area, and the dimensions are like 2.5 width by 26 feet long. Basically what we did, we ran several simulations in order to find the right sponsor. As you can see, we came with this design in which the end of the sponsor, it comes together to a single point, as well as the end. Basically what it does is that it's going to cut through the water easier, and it will use less energy in order to cut through the water. In addition to that, the catamaran hull, what it does is that it's going to allow us to go in the shallow water. Basically, under the tunnel, the water and the air is going to mix. What happens is that it's going to create like a pressure, which is going to push down to the ground. And when it pushes back to the ground, from the ground, it's going to push back to the boat, to the end of the boat, and it's going to try to lift it. So that's how that effect is called as the ground effect, and that's the one that we're going to also use in the boat. In addition to that, we have like the jack plate, which the helmsman is going to be able to move it like up or down, so he can put the propellers up or down, whether he's riding or not in shallow water. This is the structural analysis, in which we studied like the canopy. We're using 6 members, and we got a factor of safety of 12.09, and the stress of 3 pounds in each member, which means that it's safe. This is the final layout after 7 meters of decline. Basically, we try to distribute all the weight around the boat like equally. As you can see, we're carrying like 15 passengers. We're placing 5 in the back, 4, 8 in the front, and 2 in the sides. We have the center of gravity right here. We mean that we are like putting like the weight all equally distributed. In addition to that, we were asked to install like a ramp on the front of the boat, basically because it needs to be accessible for wheelchair persons, and we're having like a sidewalk, a walkway here about 36 inches wide in order to that to happen. This is the final design of the boat. Basically, the total weight, it will be 6,904 pounds, and the hull is going to displace 8,263 pounds, which gives us a factor of safety of 1.23 in order to run through shallow water. And the dimensions will be like the length 26 feet by being 9.5 feet.
Okay, as you can see in the final design, the boat has a canopy. And if you take a look at a closer look to the canopy, it holds a set of solar panels. To be more exact, we have an amount of 8 solar panels, to be correct, in top of that canopy. The main objective of this project was, besides designing a boat shallow draft, that it needed to be mainly powered through solar energy. So we did some research, and after contacting people knowledgeable in this topic, it was decided to go with the standalone photovoltaic system with battery storage. Why battery storage? Because the the energy that is going to be collected through the solar panels is not enough to power the 2 electric motors that we're going to install in this boat. So by adding a battery bank, the energy that's going to be collected through the solar panels is going to be storage in the battery banks. And then for the battery banks, we're going to be able to deliver that energy to the motors. By adding this battery bank, we need to include in the system a charge controller. And for safety matters, to be more sure in the design, we included a regular AC/DC charger, just in case some events may come up with the solar power, a cloudy day, or any of the solar panels with that. We're still going to be able to charge those battery banks by plugging the AC/DC charger to a regular 115 volts outlet. This is an electric diagram of the actual system that we're using in this boat. As you can see, the PV array is composed by 8 solar panels. They're going to give a total of 2,120 watts, which are going to be storage in our battery banks. And then we got together the battery charger. They're going to go through a series of sub-devices, and then they're going to go connect to the charge controller. And then from the charge controller, they're going to be delivered to the motors. These are some calculations to explain how the system is going to work. The power is going to be delivered through the batteries to the electric motor. So the boat is going to be powered with 2 electric motors. In this case, they're going to be torpedo. Both of them are going to be 48 PDC volts and PDC, and they require 4,000 watts to run high efficiency and the maximum speed. As per client requirements, this boat needs to move around 5 knots, which is more or less 5.8 miles per hour. So our charging time in the battery banks, if we decided, if it's going to, these batteries are going to be charged through the solar panels, it's going to take more or less 9.5 hours. If we decided to charge those batteries through the AC/DC charger, it's going to take more or less 5.6 hours. If we're running that boat at a speed of more or less 5.2 miles per hour, the draw in the batteries, it's going to take around 10.6 hours to consume all the power in those batteries. One more thing, in order to increase the safety of the wildlife in this area, and also per request of Mr. Warner, it is needed to install a propeller guard in all those 2 motors. These are the design of those propellers, and they're going to be built and installed by the boat manufacturer as well.
Good afternoon. I'm going to be speaking a little bit about the manufacturer and then the material selections that was used for the boat, and then a little bit on cost analysis. We were very fortunate enough to team up with Ralph Brown of Dreamboats Inc., based out of Hudson, which is right outside of Tampa, Florida. Mr. Brown has over 10 years of experience dealing with vessels that are primarily shallow draft, and they're shallow draft that don't give off any, they don't give any offshore characteristics or give up on any offshore characteristics. He also has issued 2 patents and has set 5 world records bringing his boats out into ocean waters. So he really was the perfect person to partner up with for this. Some of the material selection you see here is mostly for the hull, the biaxial fiberglass, the Kevlar, and the polyurethane foam is used for the hull. The polyurethane foam used to fill the sponsons and also to fill the certain cavities, which are going to help to add stability and flotation. And the core materials over here are going to be areas that go in between the layers of the biaxial fiberglass. Depending on which section it is, if it's a flat section, you'll use a honeycomb core. If it's slightly curved, you'll use the cleave cell core, and if it's a sharp curve, you're going to have the core mat that goes in between the layers of the fiberglass. And these are just a couple of pictures. We went to go visit Mr. Brown over in Tampa at his workshop, and this down here is a catamaran boat, not too dissimilar to what the final result might look like, and pictures of a shop. For the cost breakdown, we have up here on the top table, it's mainly the electrical components. On the bottom line is the vessel hull, which has a base cost of $33,000, and the rest of the electrical components. One of the constraints that we did have is that we were looking to get as many products and components off the shelf as possible. Of course, that's to reduce costs. Whenever you have to self-manufacture anything, you're going to raise the costs, and we were looking to keep costs at a minimum. But even still, we came up with a final cost of $49,790, which might seem pricey, but when you look at market comparables, we have one comparable that's also 26 inches, or 26 feet by 8.5 feet, also a 12-inch draft, which is $57,604, and another electric boat that's just under $52,000. So you can see our solar Panther boat, built by Dream Boats, under $50,000 is really better than the market comparables. And now Sebastian is going to talk about timeline and time management.
Okay, this is our project timer. We accomplished each and every task. It was hard to maintain like a time, because every time we went to talk with the client, we would change something like power in the RAM, something like that. But if you can see, we have the meetings with the clients, we visit the boat manufacturer, we go down to all the designs and simulations. If you see the blue line, that means that part 2, that's going to be the boat manufacturing and the solar panel installation, that's going to start at the end of this month, and it's going to take around 3 months. Next, this is the division of labor. It was equally divided in each teammate, and now Dave is going to talk about global learning.
Just a quick little bit about the Global Learning Initiative. Global Learning examines technologies that are developed by humans and looks at their impact on economics, politics, the quality of human life, and it's based on the local and global perspective. The process is broken down into 3 categories. With global awareness, you're looking at other areas that are similar to the projects that you're doing, in this case, mainly using solar power. There is a variety of different solar technologies that are out there. There's active and passive solar power, concentrated solar power. There is another boat that is a project that's similar to what we're doing. Jim Greer of the Solar Boat Chronicles, he has a 6,000-mile trip that he's taking around the world that's going to be all powered by solar panels. And so it's really no surprise that there's so many technologies out there in solar use. One interesting fact is that there is enough solar energy that hits the Earth in 1 hour to power all of the world's needs in 1 year. So with that much technology and that much energy reaching the Earth, you would think that there would be more solar power that's used. However, it's not, because it's been notoriously expensive, and even though there has been attempts to lower prices through subsidies, incentives, tax incentives and whatnot, it still hasn't quite caught on. And so global engagement, it's really trying to understand that really to be competitive in the market, you have to have enough efficiency and power to be really competing with the other energy technologies that are out there. And here we have a short video clip of Mr. Brown in one of his shuttle draft boats.
Okay, very nice. All right, questions?
There's two competing design constraints, I think, that I think of when I see this. It's really cool that you go to shallow to an inch, but how did you design around the classical 8-foot rollers that we typically see in Biscayne Bay every day? And having a team of somewhere around 12 to 20 people on a vehicle at a time when the big rollers will come in.
I'm not familiar with what the big rollers are that you're speaking of.
Big waves. Big waves.
Okay. Well, those obviously they have a much greater draft. So are you asking how we were able to?
The stability of the system. How stable is this under heavy waves? Let me ask that question.
Yeah, well, basically the design of the boat, because it's a square shape, right? So the boat is designed that if everybody in the boat wanna go to one side, the boat never is gonna like flip because of the because of the square of the sponsons. And basically it's like 8 inches of height, like in that part. So basically it's gonna be like more area. So it's gonna be like more like it's gonna have more stability. That's why. And in addition to that, like in that area, there are like not like big wave or big, because most of the part is like shadow. So that's another factor that things.
Well, I mean, if you go breach, for example, let me use that as an example, where I've got 8-foot waves coming down the side of this boat, or if it comes in at an incidence, how would you manage that? Did you design around those assumptions?
In addition to that, we also have, like, we forgot to mention, like, well, I think that you did, like, all around the boat, well, the deck is like high, just in case for big waves to hit it. And then in the bottom of the boat, we have like 2 holes to drain water, just in case if water comes inside the deck, it's gonna drain out. And because of the font that is built, that it has in the sponsons, also it's designed that if you cut the whole hole in parts, it's gonna float. I mean, it's meant to never sink.
There are already low draft boats and there are already solar power boats, and yours is a combination. What is it about yours that is unique to things that are already being manufactured?
Well, one of them is to hold like the amount of weight that we are having. Basically, most of the shadow boat, they're not capable of holding that much weight.
Oh.
So basically, I like for fishing and stuff like that. Like this case is to carry people. So we are like talking about like 6,904 total weight, including like 15 passengers and a helpman that is like the driver.
In addition to that, the main constraint that we have over here is it needs to be 1 foot shallow draft.
Oh.
Many of the commercial electric boats that we have up there, they don't have that draft available. They're a lot deeper.
So it's unique.
Theoretically speaking, yeah, it's been designed to work in that specific area.
And as you can see, it can even go much shallower than just the 1 foot draft. From the video that it was just a couple of inches of water.
Wow.
Did you design a place for a bar in this, or?
We're
Looks like
working
a
on
party
that.
boat to me, you know?
Well, it does have compartments for storage, so you can probably bring on a cooler with some ice and What you do with that is up to yourself.
What did
He's
you,
gonna have a restaurant too, so.
what did you learn from this as you're doing this project? Because this is an eco-friendly sort of boat. It has the, you know, all the stuff with the environment, etc. Did you learn something that you didn't know before? Or
Sure.
what did you learn?
Well, one of the main components about this project that was so unique for us is that we were working with an actual client, so it felt like real-world experience. We had issues to deal with going back and forth between the client and with the manufacturer, make sure that everybody was happy and getting the things that they needed to get out of it. Sometimes things would change in the middle, and we'd have to deal with that and sort of reassess the situation and where we were going and maybe go down a different direction that we weren't planning on to begin with. But it's really that real-world knowledge that was most unique about this. If that answers your question.
Okay, but more, I mean, was there something that as you when you went into the project you didn't know about, and then as you're doing the project you're like, oh, it's like, oh, I didn't know about this. This is new. This.
Let me, I mean, almost everything in this project is new to us. Just with the fact that we need to deal with government agencies to find out exactly what the rules and regulations are. That was a big issue. We didn't have any knowledge about solar panel, solar energy. We have to do a lot of research. I mean, contact a lot of people, manufacturers, vendors, electrical engineers. It was a bunch of. It was really fun. Yeah. I mean,
What is most surprising?
there is a combination of all of them. A big combination of all. David worked most of all with the agencies. Me and Dave as well. We decided to go and talk to solar manufacturers, solar vendors. It's a little bit about everything. Meeting with the client as well. At the end of we were almost done with this, and at the end, it was decided to include a ramp. Just that included that ramp, the hallway needed to be changed by a couple of inches. Use that couple of inches. It requires, a whole new study in order to get that ramp included into the system.
How about Taquito? Did you talk to Taquito?
We contacted the Taquito factory itself.
Because I know they also make a motor with a battery that's right on the motor.
Yes, sir. Yes, sir. But take into consideration the weight and the drag. This design, we needed to go with this special motor. It's called a 4.0 Cruise, which is gonna give you the appropriate. It's gonna cover the requirements.
And so they make a motor that's separate from the battery. The
Yes,
battery
sir.
is
Yes, sir.
separate.
You can even get the batteries from there, but it's way expensive. And you buy the batteries from there, from the shelf.
That's another thing. The motors, they come. There is an entire system. The Torquedos, they offer everything: batteries, controls, everything. But just by going with their batteries, one battery is a lithium ion battery. Just that one battery costs around $3,500. We need a.
Yeah, I don't remember the numbers, but I remember seeing now they have like a 40 or 50 horsepower motor, and the motor is 25,000, the battery is 50,000. Some crazy number.
Yes,
like
sir.
that.
So that was part of reducing cost, was mixing and matching where we got the components from.
Yeah. All right, that's it. Thank you so much.